Create a new TwinCAT project. Add a standard PLC project. And create a counter. Right-click on your solution and add a new TwinCAT HMI project. In your HMI project, click on Desktop.View. Click on Toolbox and add a text block, not a text box, a text block. Click on Properties. Click the little square on the text field to create a data binding. To see the same symbols I'm seeing, you may need to check the Show Advanced Items checkbox. There's a problem. We can't see the PLC1 symbols. This is happening because the project needs to be running so the HMI server can access those symbols. So I'm activating my configuration. Make sure that you're targeting the appropriate platform. Now I can go back to my data binding window and access the PLC1 related symbols. I'm done linking my counter to the text block element, so let's test it. Now let's add the button and control when we want to start counting. Navigate to Toolbox and add a new button. Change the display text. Let's add a new variable on our PLC code so we can control the counter. If bStartCounter is true, then we count. If false, then we reset the counter. Activate your code so we can access bStartCounter from the HMI environment. Back to Desktop.View. Select your button and click on the Properties tab. Click the lightning icon on the top right side of the tab to show events. Click the pen icon to go to the Actions and Conditions window. Drag and drop Write to Symbol into the white canvas and create a new data binding. Deploy the HMI once again and test your button. Finally, I will add another button to reset bStartCounter. This is going to be the exact same process, but I will do it anyways because not resetting bStartCounter just feels incomplete. And here you go. Now you can control your PLC without going online and manually forcing variables. You can perform logical operations on the client side using function bindings. We are going to add two inputs and send the result to a linear gauge element. Add a new button. Add a linear gauge and take note of the element's name. Double-click the button and add a write to symbol operation. The linear gauge value should receive the sum result. You can specify the element property with double columns. In our case, linear gauge, double column, value. Add two numeric inputs. Note that there isn't a convenient way to convert a string to a numerical format using data bindings, so you want to use numeric input element. Take note of the element's name, go back to the button event and create a new function binding. Click on the expanded editor and add together the value properties of your numeric inputs. And deploy the HMI once again. We've made an entire episode about the TwinCAT event logger library. You can check it out here. Now, let's see how we can display alarms and messages on our HMI in a super convenient way. First of all, it's extremely important to pay attention to your TwinCAT 3 HMI module versions. Incompatible or older versions of TE2000 or TF2000 may cause some very difficult to troubleshoot errors. You can simply avoid that by making sure that you have the latest versions of your modules and extensions. As of today, the latest version is 1.12.754.4. For those who don't know, TE2000 is the engineering environment and TF2000 is the server module. You use TE2000 to create your HMI, while TF2000 is just the server. You probably don't need nor want to have an engineering environment on every single machine you deploy your project to. I'm opening the TwinCAT Event Logger example project I've previously created. Click on your solution and select Add New Project. Select TwinCAT HMI project and name it. We want to add an extension so we can visualize messages and alarms on the HMI. Under Server, select Toggle Advanced to see all the current extensions of your project. Click on your references and manage NuGet packages. Select the tab Browse and type Event Logger. Remember, keep the versions consistent. Once it is installed, it will populate your References tab, but it won't show under Extensions just yet. You can try to sync extensions, but reopening the project was the only thing that worked for me. As you can see, it is listed now and can be configured. I'm keeping the defaults. If the icon is showing red, you can right-click on it and activate the extension. It should turn green. Let's go now to our HMI project and add an event grid. And that's it. All we need to do now is activate the PLC configuration and run the HMI on the local host. I can see a list of all my messages. It's really cool because you can filter them by state, severity, type. Let's test it out. I'm gonna go back to my PLC project and trigger some messages. As you can see, it populates the error tab. As well as my event grid. Doing the same with a different message. And voila, on the grid she goes. I hope you find this video useful, but if you still need more help with your project, Beyond Kinematics offers consulting services in PLC and HMI development, robot programming, machine vision, and data acquisition. We also have a really cool pipeline for PLC offline development. We create a realistic digital twin of your machine and hook it up to a PLC. This way we can develop your application independently from having the hardware on hand. Don't hesitate to reach out, the contact info is in the description. Thank you.